赛德
present 老师。
侯赛德 second one 6210
present 老师。
1222 this one
present 老师。
then base not here okay 6211 next 1218
Yes 老师。
伊利
Where Miss Samir?
卡西姆
present 老师。
next 高三1213
Present teacher. Present teacher.
okay next 1209
Yes, Laoshi, I'm here.
Submit 1211
Present.
6207 6207 2220
present, miss.
2220 1207
Present, miss.
艾特6206
Present, miss.
1206
I'm here, teacher.
1210
Present, miss.
1204
Present, teacher.
1205
Present, Laoshi.
华明和安民6212
Present, miss. Present.
6205
Present,
欧舒
teacher.
文
Present.
Teacher,
蕾
teacher,
蕾
陶老师。
安莫斯12161215了 OK 1202 OK 6203 Hello 6203
I'm here, Laoshi.
Next 6204
Tao Laoshi.
6208哎620862016209
Present, teacher.
1212
Present, teacher.
Hi, yes, in person.
一连
Present.
wait Rembe is not here this one 6207 6207 Hello 6207华安民1203
present,
6208 Hello 6208here. Okay, we want to see your attendance. Yeah. Do you know that the students were absent over 1/3, right? Actually, right. Let me see. That maybe you can't yeah, attendance. Absent for more than 1/3 of the teaching hours, or 6 weeks of the course, are not allowed to participate the assignment of our course. Here we have very I will show the attendance to you. Okay, but I want to change it. This means from now on, if you take our course every time, maybe you can change your this means maybe the attendance is less than 1/3. And here there are some students. I say your attendance is more than not absent is more than 1/3. Yeah, online, yes, and I will show it for you. Okay, hello, students. Everyone's attendance here. Hello, can you see this is a journalist Chinese word here. 缺勤力, this is be absent. Be absent here. This one is be absent. You can't say that. Yeah, say. Here this is the 缺勤力. I think you know this Chinese word. This is more than 1/3. It's more than 33.3%. 33.3%. 33.3%. Then you are not allowed to take the examination or take the assignment. I emphasize it. This is more than once. Okay? Participant to the assignment of our course. We can see the first one. Maybe it's later. This one is okay. It's okay. It's okay. And here we can see this boy. Here this boy is more than 33.3%, right? But this does not mean, yes, coming late is absent. I always, before our class, I set it, right? And coming late, this means absent. But here, this is not the final result. You know, it's not a final. This does not mean that this boy cannot participate the assignment. So if he takes our course every time from now on, he will be allowed to take participant to the assignment of our course. A bit late. No. It's not 3 times, right? It's an hour. It's 1/3 hours. Yeah, it's not 3 times. Here, this is you can say the 缺勤力. Here, this number is bigger than 33.3%. Right? It's not 3 times. Okay, I just see this boy. Is this boy here? Here, this boy. And we have only, as a member, we have only 8 students. It's more than 33.3%. Yeah, okay. And this page, only 1 boy, this one. And the next page, we see. Next page, okay, this one. Yulian, it's you. Now I want to change it. It's more than 33.3. But this means if you take our course every time from now on, and you can participate the assignment of this course. Okay. This is just you are very dangerous. Okay. And here this one, the ID is 211156207. What?
Present teacher. Present.
Yeah, I know you are present. I think you 的缺勤率是71.43%，是非常高的。I'm not sure if you can participate to the final examination. And here also this one. 6208. Hello, this boy, are you here? Almost every time he just attend our class once. Maybe he dropped to the school. And also this one, 6209. Yeah, because he's about 98.57, right? If it's very dangerous for him. And also this one, 6210. Okay, 6210. 6211 and 6212. 6212. You can see this is absent here. Now, I want to consider the internet problem. So before class, maybe you should adjust your equipment. It's the same with the final examination. We have the final examination on the last class, and you should adjust your equipment earlier. Okay. Otherwise, because of electricity or the internet, you can't. Maybe you can do the. You can receive our test paper or other situations. No, I won't consider this. Okay, it's the same with our. This is attendance. Now I think everyone knows he's dangerous or not, right? We have 8 students, 8个学生。This one, I don't know, this one always not here, and this one. Yes. Okay, I will give you more. This one, you can. Yeah, maybe 1216 you had serious internet problem. This means only once. It's okay, okay? This is more than 1/3 hours. More than, okay? This means if you are absent for once, it does not influence the final result, okay? So don't worry about this. I just remind students who are here. The absent is more than 1/3. For example, is 35.71的，还有 and this is also 35.71。这个是基朗100%，这个是this one 71.43的这些人，以及28.57。35.71, this 35.71, this students more. From now on, this students is more than 1/3 hours. So you should know your situation, okay? And before I sent the test paper, I will tell some students who have no opportunities to participate, okay? If I told you that you are not allowed to participate to the assignment, I won't change it, Okay, I won't change it because I already received from you this earlier today and last day maybe.88is all the learning time you should learn 88个总学时 Okay, it does not influence anything. It's just we should learn 88 hours. No, 88 学时课时 This one you should hear. This one you should notice. This one you should care about. This one. This 学勤率 here. Any questions? Of course, it influences your regular 平时成绩 regular 平时成绩 regular performance. No, I don't consider internet problems. Okay. Maybe you just missed the class once. It influenced later. Okay. Just later. Any questions? If no, we begin our class. Okay. This is if I write you are not allowed to participate in the course. This is a final decision. I won't change it. Okay, even though you hand in your test paper, I won't receive it. I won't give you score. Your score is also there. Maybe you should listen to me carefully every time and review the contents. And we will also do homework maybe later. Okay. So you must review it by yourself because we have 5 times class. And also I should emphasize that don't share your answer with any students. Okay? If I found students who have always the same answers, they have maybe this. If you do it by yourself, I think this is cheating. Both of you are cheating. Okay, so maybe both of your score is there, and I think you should also have other punishment. Maybe this is the office, the International Education Office give this law. Okay, you should remember, please remember, you don't share your answer with anyone, okay? Anyone to say your answer, please don't, okay? Just do your test paper by yourself. Don't share your answer with other students. Otherwise, I think it's a bad 坏的行为. It's a bad behavior. And if I found the test paper is almost the same, okay, I think I won't listen to your explanation. There is no reason for I won't forgive you. And also, you should know you should also remember the time. This means you have only 2 hours. Only 2 hours to finish the test paper, and you should hand in it on time. This means I think we hand in our test paper before 8:30 p.m. And if students sent the test paper maybe 9:00 p.m. I won't receive it. Okay, I won't receive it. Please just remember the time and you can 定个闹钟. You know this? Just remember. Okay. So if you see you have handing your test paper, no, I won't receive it. Yes. Because we have some new rules. It was very serious examination. This means from now on, you should review our lecture. This is our PPT. I already sent what we have learned in our WeChat group. You should download it, and review it. Okay. Just remember, any students want to ask you how to do either examination. Any students want to you give him your answers. Please, you say no. Okay. Please refuse it. Refuse it. And also you should. This means 打开摄像头. This like me, like this. See. This means 你应该prepare your test equipment in advance and make sure the video is facing your test. This means like this here. Like this. It is open. This is prepare your test equipment and make sure the video is facing your test. Here, this is open the video, and this is my example. This is my test. You should like this, and I will say right. You do it by yourself and using the mobile phone. Okay, and only the special time you should upload your answer. Okay, so it's a very serious exam. Because I emphasize others for many times. So I want to, if some students broken these rules, and I want to forgive him or her, and maybe I want to receive. This is not maybe I want to receive your test paper. Okay, just when your score is there, please don't find me. I want to change it. If you have any other questions, you can. To find the International Education Office, you can go to, maybe you can go to contact with office, the teachers in the International Office of Teacher. Okay, clear? Yes, PDF. Yes, PDF, but now I haven't found a better way for us to send the test paper. Maybe before our class, I will make it clear and I will explain it to you. Can you give us some extra time for maybe, but not much, only the last second classes. I want to make the point, do some extra exercise. Clear? Okay, it's clear, we begin our class. Okay. You have some conceptual problems. What is conceptual problems? Concept, C1CEPT， 概念性的问题吗 ？Basic concept. Maybe you read the books again and again. Okay. And now, last time, I hope you remember, we have learned the implicit differentiation. And today we will learn lecture 4. It's about the applications of the derivative. Yeah, but I just you are weak at mathematics. What could I say? Just good luck for you. And we will learn the maximum and minimum. Often in life, we are faced with a problem on finding the best way to do something. For example, a farmer wants to choose a mix of crops that is likely to produce the largest profit. A doctor which is to select the smallest, this is 剂量, that sort of a drug that will cure a certain disease. A manufacturer will like to minimize the cost of distributing its products. Often such a problem can be formulated so that it involves maximizing or minimizing a function over a specified site. If so, the methods of calculus provide a powerful tool for solving the problem. Supposing that we are given a function, here fx, and a domain s as in figure 1. Here, this is figure 1. We have a function. This is the curve of this function, and the domain s in figure 1. We now pose the 3 questions. The first one, does fx have a maximum or minimum value on s? This means we want to find a maximum or minimum value. If it does have a maximum or minimum, where are they attained? Okay, where are they attained? If they exist, what are the maximum and minimum values? This means if they exist, we want to calculate the maximum and minimum values. Here. So answering these questions is the principal goal of this section. We begin by introducing a precise vocabulary. Definition, this is let S, this is the domain of F, contain the point C. We see that here FC is a maximum value of F on S. If this means FC is greater than or equal to Fx for Rx in S. And the second, FC is the minimum value of F on S. If FC is less than or equal to Fx, this is the minimum for Rx in S. Third one is FC is the extreme value of F on S. If it's this means either or either. It's either a maximum or the minimum value. Okay. Extreme value. In Chinese, this is 极值. Okay. Extreme F is extreme value of F on S. If it's either the maximum value or the minimum value. Then the function we want to maximize is the objective function. This means f here. This is objective function. 目标函数. Yes, lecture 3 finished. The last lecture finished. The last content is the implicit differentiation. And now we will talk about the existence question. It means does F have a maximum or minimum value on S? The answer depends first of R on the site S. For example, we have Fx is 1 over x. Here, this is 1 over x on S. The domain is from 0 to infinity. It has neither a maximum nor a minimum value here from 0 to infinity. You know, we x is near 0 from the right. Fx, we know, it approaches infinity, right? Infinity. And we x approaches infinity, we know y approaches 0. So on 0 infinity, no maximum or minimum. On the other hand, the same function is the same objective function, but different site. The site is on 1, 3. And Fx, the objective is 1 over 3. And we can find the maximum is Vx is 1. The maximum is 1. And Vx is 3. The minimum value is 1 over 3, right? And then we will also change the domain. Here is this closed interval, but here is not a closed interval. It's from 1 to 3. Some solids are not finished. You guys remember it finished. Oh, you see some exercise. We haven't talked about it, right? Yes, maybe you can do it by yourself after our class. And if you have more time, we can explain them. But now we will learn new knowledge. Okay? Here is from 1 to 3. 1 to 3. Here we know no maximum because we know Bx is 1. We have the maximum is 1. But here is 1 is excluded. So it's just 1 over x. It's near 1, but not 1. Okay, it's near 1, but not 1. And the maximum is 1 over 3. Still, Vx is 3. The minimum value is 1 over 3. And so the answer, this means the answers depend on the domain, the site, or depend on the site S. And the answer also depends on the type of function. We consider the discontinuous function g, defined by, here, this is g. G is in 1, 2, 2, in 1, 2. In this interval, gx, we find this the x. In 2, 3, gx is x minus 2. And the site is 1, 2, 3. Now here, g has no maximum value because we know maximum, we find Vx approaches 2. Gx approaches here, this one, right? It gets absolutely close to, but never attains it. Never attains it. This means you can find any point that Gx is 2, right? Gx is not 2 in this interval, 1, 3. So it gets absolutely here. Absolutely, this is a circle, right? So it's absolutely close to 2, but never attains it. Never attains it. Never attains it. However, G has a minimum value. G2 is 0. Here, from this graph, we can say the minimum value Vx is 2. We have G2 is 0. So this means we got the maximum value, but no minimum value. Why? Why I said I'm present, but you write me absent? When? Which time? I think I have checked it for every time. Okay, so we have maximum, we have no maximum, but we have minimum is 0, right? From this. So this means if we find the maximum value and the minimum value, this is the existence question. We should notice about the site and also has a relationship with the function. And then we have a nice theorem that answers the existence question for many of the problems that come up in practice. There is intuitively obvious. A rigorous proof is quite difficult. We leave that for more advanced textbooks. We have theorem A. It's very difficult to prove it. We have max-mini existence theorem. This means we want f is continuous. Continuous. Here, this is the restrict on the function f. It must be continuous. And The restriction on the site, this must be a closed interval. This is a closed interval AB. A closed interval AB. D, F attains both a maximum value and a minimum value there. Okay, we have two conditions. This means note the keywords in theorem A. The keywords is F is required to be continuous, and the side S is required to be closed interval. Okay, F is required to be continuous, and the side is required to be a closed interval. Then F has minimum and maximum value there on this interval AB. And then we want to find also we want to get the maximum and minimum value, and we also care about the extreme value. Extreme value, and I hope you remember extreme value. This is either the maximum or the minimum value is called extreme value. 是最大值或者是最小值，都称为是极值。And usually the objective function will have an interval I as its domain, but this interval may be any of the 9 types discussed in section 0.2. Some of them contain their endpoints, some do not. This means we have linked the interval, we have closed interval, open interval, and the contain endpoints. The left endpoints or right endpoints. And for instance, IAB contains both these endpoints. AB contains only its left endpoint, and AB contains neither endpoint. Extreme values of functions defined on closed interval often occur at endpoints. Often, it just often occurs at endpoints. Here, maximum, minimum, maximum, minimum. And we will also many definitions. This is called stationary point. This means if a prime C is 0, we calculate the derivative of f and we find a point C such that f prime C is 0. Then we can say a stationary point. The name derives from the fact that at a stationary point, the graph of f levels off. Since f prime C is 0, this means the slope of the tangent line. The slope of the tangent line is 0. So since the tangent line is a horizontal line, k is 0, so the tangent line is horizontal. Extreme values often occur at stationary points. Here, no. Finger 5, we have the stationary point. This means f prime C is 0. So the tangent line, the slope of this tangent line. The slope of the tangent line is 0. It's 0, so the tangent line is horizontal, is a horizontal line. And we find here, we have the maximum value, and also this the minimum value. We can find the tangent line is a horizontal line. This is just often, okay? Often occur. Finally, if C is an interior point of I, where f prime fails to exist, we call C a singular point. Singular point. This means f prime. If f prime C fails to exist, we have this SINGU area, singular point. It's a point where the graph of f has a sharp corner, a vertical tangent, or perhaps takes a jump, or near where the graph wiggles very slightly. Extreme values can occur at singular points. You can see this stationary points at C1 at prime C0, at C2 at prime C0, at C3 is also 0. But here at this point, we know this is C1. We have the maximum value, so this is also the extreme value. So extreme value may also occur at singular points, because at here they have a sharp corner, right? They have a sharp corner, and here at this point we find the minimum values, so it's also extreme value. But here a prime C does not exist, so this means it has a jump, takes a jump. And these three cancel points, endpoints, we know here endpoints, A and B are endpoints. A is the left endpoint, B is the right endpoint, and stationary point. This means at prime C is 0. Endpoint, stationary point C, and singular point 3 is at prime C fails to exist. Fails to exist. These 3 points are the key points of maximum minimum theorem. Any point of one of these 3 types in the domain of a function f is called a practical point. Here, this is called a practical point. This means if I want you to calculate the practical point, you should find endpoints, stationary points, and singular points, right? These are called practical point. And for example, we have find example here. Example 1 is find the practical points of f(x) minus 2x cubed plus 3x squared on this one. Practical points containing endpoints, stationary points, and the singular points. So first, it's easy to know the endpoints. Endpoints minus 1 or 2 and 2, right? And find the stationary points. This means we should calculate f prime x is minus 6x squared plus 6x, right? Let this is 0. From this, we can obtain x is 0 and x is 1, right? So our x is 1. So containing 0, 1. These are stationary points. And the practical points, the singular points, this means f prime x fails to exist. We can find there are no singular points. Thus, the practical points are minus 1 or 2, 0, 1, and 2. Example 1. And now we have the practical point theorem. It means if let f be defined on an interval I containing the point C, if fc is an extreme value, then C must be a practical point. That is either C is an end point of I, a stationary point of I, that is a point where f prime C is 0, or a singular point of f, that is a point where f prime C does not exist. Okay, so this is fc is an extreme value. Then C must be a practical point. Must be a practical point. That is, if either C is an end point of f, of I, a stationary point of f, a singular point of f. If this is Not a problem. Which time? Why I should check it again? Because our students are learning, right? I can't always check again and again. Maybe you should you attend our class from now on every time. I think you can participate to the assignment of this course. Okay? Let me see. Here, I change it for you only once. I want to change it only once. I give you one chance. Okay? Next time, please don't tell you right. I make you be absent. Just for once. 6207. Now your station is be present, okay? And now I think this. Maybe I hope you understand this learning, this theorem B, because I think it's maybe a little difficult to operate. You try your best to understand it, okay, and explain it. Why? Why FC is an extreme value means it must be a practical point. First, we consider because FC is extreme value. This means FC is either a maximum value or a minimum value. Okay, we consider the first case. FC is the maximum value of F on R, and suppose that C is neither. Oh, okay. Since neither an end point nor a singular point, we must ensure right C is a stationary point, right? Listen, we consider the first case, FC is a maximum value of F, and we suppose that C is neither an endpoint nor a singular point. We must ensure that C is a stationary point. And since FC is the maximum value, this means fx is less than or equal to fc for all x in I. That is, fc minus fx minus fc is less than or equal to 0. And thus, if x is less than, we have x minus c is less than 0. So we have fx minus fc over x minus c here because it's negative. So negative over negative is positive, right? It's greater than or equal to 0. And whereas if x is greater than c, this means negative. And here x minus c greater than 0. So this is positive. Negative, positive, so it's negative. It's negative. But a prime C, a prime C exists because C is not a singular point. Consequently, when we let x prime C from left in 1, to calculate this limit x approaches C from left in 1, and so we let the limit x approaches C from right. X approaches C from right, this means x is greater than C. We obtain this actively from this. We have the limit is equal to f prime c. Here, this is f prime c is greater than to 0. At this, we find f prime c this is less than to 0. Here is greater than to 0. We can conclude that f prime c is 0. As there, right? As there, okay? And the case where FC is minimum value is handled similarly. Here we have put right. If it's a maximum value, suppose it's neither an endpoint nor a singular point, we must show right C is a stationary point. Because it's not a singular point. So this means F prime C exists. Does exist. We want to provide C is a stationary point. This means we want to prove F prime C is 0. Okay. Why? We can say Fc is a maximum value. So Fx is less than or equal to Fc. And we have Fx minus Fc negative. Here, negative. Then we consider x less than c and x is greater than c. We find this positive, negative. Then we take the limit. We consider the left-hand limit and the right-hand limit. Find this F prime c greater than or equal to 0, F prime c less than or equal to 0. And Fc does exist. This means this is the left limit, right limit, they are equal. So F prime C must be 0. This means F prime C is 0. This means C is a stationary point, right? C is a stationary point. Just try best to understand this, okay? Now we will learn how to find the extreme values. In view of theorem A and B, we can now state a very simple procedure for finding the maximum and minimum value for a continuous function f on a closed interval. First, we should find the critical points of f on I. For all critical points, evaluate f at each of these critical points. The largest of these values is the maximum value. The smallest is the minimum value. Okay? The smallest is minimum value. If you maybe give you an example to understand this, example 2 is find the minimum and maximum values of fx is x cubed on -2 and 2. First, please tell me. Find step 1. Step 1, find the practical points of f on I. Please tell me the practical points. Please tell me the practical points. 0, 0, 1, -2, right? Yes. Yeah, 0, -2. Because when practical points contain endpoints. Endpoints is -2, 2, right? And the stationary point. This means the stationary point, we will calculate F prime C is 0, right? F prime C here, this is the 3C square is 0. We can find C is 0. So this is the stationary point. And also the singular point here, there's no singular point because at every number F prime X exists, right? F prime X exists at every real number, so no singular point. So the first step, find practical points. We have 3 points. And step 2 is evaluate f at each of these practical points. The largest of these values is the maximum value, and the smallest is the minimum value. This means step 2 is to calculate f -2, f2, and f0, right? F0. Calculate f-2 is -2 cube is equal to -8. And f2 is 2 cube is equal to 8. And f0 is 0. Then we can find the largest values is equal to 8. So this is the maximum value. And the smallest is the minimum value. So find the minimum value. Okay, so practical points, we have 3. And the largest one is 8. The maximum is 8, the minimum is -8, -8. Example 2, understand? Hello, students online? No? Okay, no questions? Okay, we'll continue. maybe example to it by yourself. Is f(x) is x the power is 2 over 3 is continuous everywhere, but its maximum and minimum values on this closed interval is -2, -1, 2. You should write 2 steps. The first one is to find the practical points, and the second step you should find the smallest and the largest values, and the smallest values the maximum value, and the largest the smallest is the minimum value, and the largest is the minimum value, right? Okay, let's have a try. Give you 3 minutes. 3. Okay, 3 minutes. Quickly. The first step is very important, because if you find the wrong practical points, this means you have the wrong largest and smallest numbers, and then you have the wrong minimum and maximum values. And if you finish you can show your answer to me. Okay. Hello, please tell me the practical points. No one gave me critical points. Critical. What's a critical points? Critical points. Hello? -1, 0, 0, 2. Right? We know -1 and 2 are endpoints, and 0. Please tell me 0 is the what point? Yes, I know it's correct. Critical points. Singular points. Singular point. The single point. This means we have 3 correct critical points. Let me check. Yes, right. It's -2. No, -1. It's not -2. Okay, -1. So this means we have 3 critical points. We find a prime x, which is never 0. Okay, however, this means a prime 0 does not exist. So 0 is the critical point. And R as other endpoints is -1 and 2. We find F -1 is 1, F0 is 0, and F2 is about 1.59. Thus, the maximum value is the smallest. The biggest one is this one. The minimum value is the smallest is 0, right? So, and we have give the graph. From graph, we can also find minimum, maximum, right? Okay, maybe not. It's not just not homework. 513, please. 513. Do it now. To them now. Quickly. Identify the critical points and find the maximum and minimum values on the given interval. Oh, maybe only 13, okay? Because it's 5. If you know how to do 13, I think it's okay for number 5. 13. Hello? Quickly, 13. Quickly. First time, please find the critical points and then find the maximum and minimum value. Please tell me your critical points. Let me see. Anyone give the critical points? 13. Anyone? Hello, anyone? I'm waiting answers. 0, 1. Only 2 points. 0, 1. -1, 1. Oh, minus 13. Are you sure? Critical points? 0, -2, 0. Yes, we don't do 5. Sorry, just the 13. Just 13. Quickly. Hello, anyone? 13. Okay, I think this is very easy for you to find just find the critical points. -2, 0. No. 0. No. What's your critical points? Yes, it's -2, 0, 2. Right? Let me check it. Prime x is equal to, so endpoints -2, right? So prime x, we want to find the stationary point and a singular point. Prime x is 4x cubed -2 minus 4x, right? And we left this is 0. So this means x cubed minus x is 0. We find x squared minus 1 is 0, right? So we have 0 stationary point, 1 minus 1. Yes, let me see. Hacemos. Oh, you forgot the 0. Hacemos. You forgot the 0, right? 0. We have 5 critical points, right? And we calculate one by one. F-2, F0, F2, F1, F-1. Then you can find the biggest numbers is maximum value and the smallest minimal value, right? So I omit this precise. I think you can calculate it later, right? So okay, now we continue. Okay. Now we will answer this is sorry, I forgot this is 单调性 Chinese. Do you know how to pronounce it? Maybe you can tell me. Yes, monotonicity. Monotonicity, right? Monotonicity and yes, monotonicity and yes, right, great. Monotonicity and concavity, right? We consider the graph in figure 1 here, like this. No one will be surprised when we say that f is decreasing to the left of C. Here, it's decreasing and it's increasing to the right of C. But to make sure that we agree on terminology, we give precise definitions. This is decreasing, increasing. We have the increasing and decreasing and strictly monotonic. Definitely, if f be defined on an interval I, maybe open interval, closed interval, or neither, we see that f is increasing. It's increasing on I. If for every pair of numbers x1, x2, if x1 is less than x2, we have implied that fx1 is less than fx2. This is increasing, right? And decreasing, this means for every pair of numbers x1 and x2 in I, x1 less than x2 implies fx1 is greater than fx2, right? It's decreasing. And f is strictly monotonic on I if it's either increasing on I or decreasing on I. Okay? It's strictly monotonic. And how shall we decide where a function is increasing? We could choose graph and look at it. But a graph is usually drawn by plotting a few points and collecting these points with a small curve. Who can be sure right? The graph does not wiggle between the plotted points. Even computer, algebra systems, and graphing calculators plot by simply collecting points. This means we need a better procedure. Right? We need a better procedure. Here, we will use the derivative, the definition of the derivative to give the monotonic. This is the first derivative and monotonic, because we know if we just give the graph, it's not maybe it's not the better strictly monotonic. This means increasing like this, decreasing like this. This is either increasing or decreasing, because this is f is strictly monotonic on I, again interval I. Now, in Chinese, 它是单调增加的，或者是单调减少的，我们就称为是它是严格单调的。You know? You understand? Strictly monotonic. Okay, this means is increasing or decreasing. And we will use first the derivative and monotonic. I just monotonicity. Recall that the first derivative f prime gives us the slope of a tangent line to the graph of f at the point x. Thus, we know if f prime x is greater than 0, this means the tangent line is raising to the left, suggesting that f is increasing. Do we have finger 2? Oh no, maybe we don't have finger 2. Yeah. Increasing. Similarly, if f prime x is less than 0, then the tangent line is falling to the right, suggesting that f is decreasing. We can also look at this in terms of motion along a line. Suppose an object is at position as t at time t, and its velocity is always positive, that is, as prime t is greater than 0, then it seems reasonable that the object will continue to move to the right as long as the derivative stays positive, right? We have this is as t. If this is as prime t is positive, and this means that this object continue to move to the right. In other words, as t will be increasing function of t, because it's always to the right, so the position is increasing. These observations do not prove theorem A, but they make the result plausible. We postpone a rigorous proof until section 3.6. We have monotonicity theorem. This means we will use the first derivative to decide or to give or to obtain the strictly monotonic this, right? And let f be continuous on an interval I and differentiable at every interior point of I. We have if f prime x is greater than 0, this is the first derivative is positive. For all x interior to I, the f is increasing on I. because we know a prime x is greater than 0. A prime x is greater than 0. This means the tangent line is the slope or the tangent line is positive. So the tangent line is raising to the right. And if a prime x is less than 0 for all x interior to I, then f is decreasing on I. This is f prime x is greater than 0 is increasing. Prime x less than 0 is decreasing. Okay. And now we will use theorem A to decide whether a function is increasing or decreasing. Not we don't use the definition because it's difficult to prove it by definition. We will use theorem A usually. For example, we find this f(x) is 2x cubed minus 3x squared minus 12x plus 7. And where f is increasing and where is decreasing. Okay? And so we know we should use theorem A. This means the first step we should calculate f prime x is equal to 6x cubed minus. Now we will do it together. Please don't say the read the answer. Do it here. Here. f(x) is equal to f prime x. Please tell me f prime x quickly. F prime x. 6x squared. 6x minus 12. Right. Okay. And then we find this 6. This x squared minus x minus 2 is equal to 6x minus 2 x plus 1. Right? X minus 2 x plus 1. Is where f is increasing and where is decreasing. If it is increasing, this means we write f prime x is positive, right? It's positive. This means 6 is positive, right? We can solve this inequality. We already factor it already, right? Please tell me. This means this implies is positive because 6 is positive, right? And from this, we have the split points. Maybe you have the split points is 2 and minus 1. Or we can solve this equality directly. From this, we can find 2 minus 1. This is 0, 3 interval, right? 3 interval minus 1. In this interval, we choose a test point minus 2. Okay? Minus 2, we can find this is equal to, from this, we can find this is equal to, minus 2, we find this minus 4 times minus 1. So it's positive, right? So in this interval, positive. Interval negative, this interval positive, right? So until this is positive, this means x is less than minus 1, or x is greater than 2, right? Here this f prime x is positive. This means where f is increasing, where? In this interval. You need infinity, right? And where is decreasing? This means less than 0, right? Where? First, negative. So we are on this interval, minus 1, 2, right? On this interval. This is which I've solved, already solved it, right? Example 1. Understand? Okay, example 1. Any questions? No? Okay. Okay, we continue. Now, this is what we have to write. f is increasing on minus infinity to minus 1 and 2 to infinity. Here, this light, here minus 1 is included and 2 included. And also, you write like this. This means it does not matter for 1 point. You should know this included. Right, and decreasing on this point. Note that the theorem allows us to include the endpoints. This means the theorem allows us to include the endpoints of these intervals, right? So endpoints. And even though our prime x is not there at this point, the graph is showing finger from. So this means this point does not matter, okay? It does not matter. You can also write like this. It's also right. Okay, it's still right. We just find an interval, not only a point. So right. You don't understand what? I just get it. Get what? Couldn't understand.
I couldn't understand the
So
last
here
math.
is-
Could you
The
please
last
explain
what?
it again? The last line,
Mhm.
the last math you solved. The last math you solved
The last-
already. That's the last math. The last problem. Yeah. I just couldn't get it.
Previous. This one.
No,
The
man.
last bit.
Previous slide. Yeah, exactly. This is.
What?
Ma'am, exactly.
This page.
I just couldn't do it. Can you please explain it again?
Repeat it again.
Yeah, if you.
Repeat which part?
Yeah,
Which part?
this one.
Which
in
one?
Second line. Ma'am, in second line.
Second line.
Yeah.
In PPT or I write.
No, ma'am. No, ma'am. Not here. At the first line after second line. Yeah.
This line.
No. Upper one. After on derivative, like when it is like 6 and then bracket x square minus x minus 2 and then equal 6x minus 2 into x plus 2 at the
Pardon?
could you please explain it again? Yeah,
This.
the upper line, first line, ma'am, first line that you
First
solved
line?
already. Yeah,
I
first line.
solved.
Yeah, exactly that point.
This.
Yeah, exactly.
Or this.
Yeah, exactly.
Comment. I don't know. You don't know this one. Why this one is equal to this one?
Exactly, miss.
This is a factor, right? We have learned how to factor this is the quadratic or quadratic. You don't know this
That means
one?
it's a
Why?
middle factor. Okay.
You don't know why this is equal to this one?
Yeah, ma'am. This is exactly. Could you please explain?
I think in lecture 01
Ma'am,
we have already learned how to factor this. Here, 6 is here.
Yeah, could you please
Can I
explain it?
check? Maybe you can
that's the
like
point I
this.
can understand.
Hello, you can like this. You can write draw the root. You can calculate the root. We have the root, right, is right? We have learned it. Lecture 01. Or here. 0, we know x will write 1, 1. Minus 2, we can write is minus 2, 1. Here. So this 1 minus 2 is minus 1. Of course, this is minus 1. So the x minus 2 times x plus 1. x x squared minus 2x plus x minus 2. And we see in chapter 0, we have learned how to factor. Do you know how to factor? Do you know how to factor a quadratic equation? 知道 okay.
Okay, miss.
Quadratic formula. Now I will show it. You should review, okay? We have a discriminant, so we have the quadratic formula. Most students will recall the quadratic formula. I think you have learned in high school, right? Quadratic formula. Now, if you notice quadratic formula here, now we have first, if we want to solve the inequality, first you find the two solutions of this one equality. By the quadratic formula, we have x1 and x2. So this one is equal to x minus x1 times x minus x2, right? Any questions, for example, for example 1? Any questions? Do you understand it? Understand it? And so now we have with the first derivative. By the first derivative, we can find the where f is increasing and where f is decreasing. Now we will learn the second derivative and the concavity. A function may be increasing and still have a very weakly graph. To analyze the wiggles, we need to study how the tangent line turns as we move from left to right along the graph. If the tangent line turns steadily in the counterclockwise direction, we see that the graph is concave up. If the tangent turns in the clockwise direction, the graph is concave down. Both definitions are better stated in terms of functions and their derivatives. Now, increasing is increasing but weakly. It's concave up, concave down. Here we have the definitions for concave up, concave down. Here, let f be differentiable on an open interval. F, as well as its graph, is concave up. Here, concave up on I, if I prime is increasing. Here, like this. Concave up, like the graph like a cup, right? This is concave up. And concave down, like this. This is concave down. Concave up, concave down. And from the graph, we can know it's concave up or concave down, but how to decide it? And we will use the second derivative. Here, the graphs in figure 7 will help to clarify these notions. Note that a curve that is concave up is shaped like a cup, right? It's shaped like a cup. This is concave up, this is concave down. This one is first concave cup and then concave down, right? It's concave up, concave down. And we can see, if it's concave up, we can have this is the tangent line at this point, at this point, and at this point, this tangent line. And this is x1, x2, x3, x4. We can see the slope. We can see f prime x1 and f prime x2, f prime x3, f prime x4. Please tell me which one is the biggest. Which one is the biggest? The slope. F prime x 1, F prime x 2, F prime x 3, F prime x 4. Which one is the biggest? For concave arc. You see? Which one is biggest? Hmm? Which one? F prime x 4. This is the biggest one. This means this the smallest, right? So it's less than equal to less than equal to less than equal to, right? So from this we can see F prime x is increasing, right? F prime x is increasing, then we have this function is concave up. Otherwise, or no otherwise, or if F prime x is decreasing, and just write like this decreasing, it's concave down, right? Concave down, and concave down. And for its left is concave up, the right hand is concave down. And we know if a prime is increasing, this means F double prime. This double prime is negative or positive. Negative or positive. Hello, this time if F prime x is increasing, F double prime is negative or positive. Negative or positive. Here, concave. Here, F prime x. Prime x is increasing, right? Prime x is increasing. This tells me F double prime is concave, is positive or negative. Quickly, think about it. It's positive or negative. Or please tell me that. You know, we just learned where F is increasing and where F is decreasing, right? You know, yes. If Fx is increasing, we find F prime x is positive, right? If Fx is decreasing, F prime x is negative, right? So, of course, if double prime x is increasing, this means, if F prime x is increasing, this means F double prime x is positive, right? So, F prime x increasing, this means concave up, concave up. So from the second derivative, this is if the second derivative is positive, the F is concave up, right? Concave up. And if it's double prime is negative, this is concave down, right? Concave down. I think we have theorem B, concavity theorem. This means in view of theorem A, we have a simple criteria for deciding where a curve is concave up and where is concave down. We simply keep in mind that. Keep in mind that the second derivative of f is the first derivative of f prime. Thus, f prime is increasing if f double prime is positive. It's decreasing if f double prime is negative. It's negative. So we have theorem B is concavity theorem. Let f be twice differentiable on the open interval. F double prime is positive for all x in I. Then f is concave up, right? F double prime x is negative for all x belongs to I. Then f is concave down on I, right? So for most of the functions, this theorem reduces the problem of determining concavity to the problem of solving inequalities. By now, we are experts at this because we already know how to solve equalities. Okay, maybe I think you should think about exam 3 by yourself. Exam 3. Let's try to finish it. This is where is f(x) is 1 over 3x cubed minus x squared minus 3x plus 4 increasing. Increasing, concave up and concave down. This means you have 4 questions. First is increasing. Where is increasing? Second, where is decreasing? Third, where is concave up? And where is concave down? Okay, let's have a try. Exam 3. Hello, anyone finished it? Can you show your answer to me? Hello? Can you see? Please tell me where is increasing and where is decreasing. We just learned it. Oh. 3 minutes. Well, you have spent 3 minutes. Have you finished the where is increasing or where is decreasing? Do you have find the F prime x and find the F double prime x? Hello, students online. Please, can you send your answer to me? Share your answer. Where is increasing and where is decreasing? No one finished it. I don't, because I believe you can do it. It's just maybe you are not listening or not doing, because it's not difficult. Okay, it's not difficult. It's easier than what we have learned before. Why no one shows your answer? I don't know why. Let me see. Which one? Lele, do you have finished it? Lele. Hello, Lele. Not yet. Okay. Next, I don't know your Chinese name. This one. 2115. Maybe this is a boy. Think. It's difficult. It's difficult. Is it complex? Sure. I think it's easy. So just give you 3 minutes. Just you finish in 3 minutes. But why I haven't seen any answer from right now? I haven't seen any answer. Explain or give you more minutes to do it. Explain, okay? And now, let me say, prime x, are you right? For this line, are you right? Right or wrong? Are prime x right or wrong? If our prime x is wrong, maybe our double prime is wrong, we increase all are wrong. Right? So I think our prime x and double prime x here is 2x minus 2 is 2 times x minus 1, right? So we want to find out where is increasing and where is decreasing. This means with the solving the equalities, the first equality, the first derivatives. The first derivative solve this equality and its opposite. We can find the increasing interval and decreasing interval. We can calculate f is increasing on. I don't check it. Maybe you can check it. You can use the test point. Find this positive, negative, positive, right? So the increasing interval is minus infinity, minus 1, and 3 infinity, right? I don't know why you haven't finished the first. Why? Do you find this one? No, do you know where is Jean? If you find this one, you can solve this equality. Because in lecture 01, we have learned how to solve the potential equality. Okay? Because I think you are experts at this part, solving equality. Okay? And then, similarly, we solve f double prime x. This is 2x minus 1. We let it is greater than 0 and less than 0. Without greater than 0, this means it's concave up on 1 infinity and concave down on minus infinity 1. So we have the graph just like f double prime. Negative, positive. So 1 to infinity, concave up. Minus infinity, concave down. Concave up, concave down. Any questions? But I don't know. I don't understand why it's not solve this. Why you don't you give me the answer? I think you spend a long time. Well, exam 3 is not difficult. Hello, any question for exam 3? Any questions? No question, are you sure? Any questions? No question. Okay, we begin. Here, this is the graph. We have find some points and plot these points with small curve. Because we know it's increasing and decreasing, it's concave up and concave down. So we have the graph like this. Okay, give you another chance. Let's try to do this one. Yeah. Example, like where is gx concave up and where is it concave down? Okay, the last this one, ignore it. Just find where is concave up, where is We have 7 minutes. I hope you can finish this one, the last one. And later we will review the answers. They review the processes and you can check if whether you are right or wrong. Anyone? Let me see. Oh, 7个哦，怎么了？With the girl. Okay. Wow. Wow. Beautiful answer. I'm so glad as receive the answer. Wow. I like you, Lily. I really hope I can. I really hope you can. You are here. Oh, let me see. This means we should calculate the quotient, we should calculate the first derivative and the second derivative, right? And we should use the quotient rule again and again, maybe twice. Really? Oh, do you find the first derivative? What are you doing? Huh? Why? Let's calculate the first derivative. Do you have finished the first derivative? Double derivative. How about double derivative? No. Your first derivative is wrong. Why? Well, this is horrible because the first derivative is wrong. Of course, the second derivative is wrong. Of course, where is concave up and where is concave down is also. Okay. Now, maybe you can, I don't know where is your wrong. We just use quotient rule, right? Just the quotient rule. So you should be careful. Quotient rule here, we have D double prime X, G double X prime X, right? And now, here, this means we began our study of this function exam 2. We find the increasing and decreasing intervals, and to analyze the concavity, we calculate G double prime X. But the G double prime X is 1. Okay, we can find is this one. G double prime. Because we know 1 plus x squared cube, this is always positive, right? So if we let G double prime x is greater than 0, this means the numerator is greater than 0, right? This we have is x squared minus 3 is x minus the square root of 3, x plus the square root of 3. Right? It's greater than 0. And we can solve this inequality here, next page. We can, since denominator is always positive, we need only solve this positive and its opposite. The split points are this one and this one, and these 3 split points determine 4 intervals. After testing them, we conclude that G is concave up, concave on, and it's concave down. Concave down. And check Lily's answer. Concave up. Right. Concave down. Right. There, square root of 3. this graph. And the questions. So this means you must grasp how to calculate the W integral, how to calculate the inequality, right? Just these 2 points. Inequality, how to solve the inequality, right? If you know these 2 points, I think exam 4 is easy for you. But if the first derivative is wrong, I think the second is also wrong, and where is concave up and where is concave down, you can find it, right? Okay, hello, bye-bye. Maybe see you tomorrow. Oh my God. And the next day, see you tomorrow, Monday, Tuesday, Thursday, Wednesday, right? Okay. Yeah. What's wrong? No, tomorrow. Yes, we have class Wednesday. 星期一、星期二、星期三、星期四。Oh, we have a class online maybe from next week. Yeah, next week we have class online. Next week. Yeah, next week. Huh? Next week you have class online. And you also have our test examination one of students. Bye. Bye-bye.